Ali.
Okay. Yes. Yes.
Start.
Please you start.
Okay. So uh, we are trying to build a quantum computer. So quantum is a phenomenon where in classical, two different states. States like um, mm, a cell could be a cancer cell, could be a normal cell. The two very different state. Suppose if it is quantum phenomenon, then a cell could be either in a quantum cancer state or it could be in a normal state. And depending on your measurement, you could see sometimes it is working as a cancer cell or sometimes it's working as a normal cell. So there is no guarantee. So what happens is cancer cell property, there is a particular property which is called say apoptosis. Apoptosis normally you should see in normal cells, but in cancer cell, it try to divide and divide and divide, and you can't trigger. So that's the difference. But normal cell, little bit of abnormality in the environmental condition, it will undergo apoptosis. So like they are disciplined worker and they are indisciplined worker. So this is a property. So what we physicists do, suppose we have two different balls, one red ball or a white ball. It's a combined state and it's undefined state. So now as a biologist, question will come in your mind that Ivan, what is the advantage of that? If there is a clear depiction that either it is this or that, then we can use it for technology. But how can something mixed together, it's a superposition of two different states, you cannot separate it, and it's so unpredictable that if you measure it in some way, then you will get something, and then measurement goes different, and then it can. And also statistically 100 times you measure it, 60 times, 70 times you will get something, 30 times you will get something different. So when there is so much unpredictability, then why do you want to use this kind of quantum phenomenon to make a computer, quantum computer or something like that? So the answer is, suppose there is a property that is shared between you and me, and for an example, say my amplitude, or if you just come here, um, uh, say our phase, or our signal or our color that I am radiating and you are radiating, and that value is red, and red is say 1. So if our property is entangled, we are connected by quantum property, quantum phenomenon, then if redness for me is 1 and redness for you is 1, if somebody measures your redness, get 1.4, not 1. Point 0.4 comes from my redness, even though it is measured on you. And if somebody measures on me, they will get redness 1.4. So 2.8 together. So we should get 1 plus 1, 2, but we will getting 2.8. Much more than what you have, much more than what I have. Okay, so this is quantum. Now again your question would remain the same, that Anirban, even if shared, what are we going to get? So if you come here and you look at the screen, I'm standing here and I'm changing, I'm creating something. You'll see wherever I make the periodic motions, slowly more number of circles will start producing. So we look at a periodic event. So this is exactly how the brain functions. We learned it from proteins and microtubule and neurons, and we have given the name as the geometric musical language. So all these circles that you are seeing, they are clock. So depending on each clock or periodic motions that I have of my hand, corresponding frequencies are generated. Those frequencies are coming here, and from here the frequencies are sent to there, and to each this kind of box and this kind of gel cavity like situations, and you have all 16 direction, those clocks are coming here. Okay, from the clock frequencies are going there. We have organic jelly, and organic jelly, imagine you have a magical, we call it brain jelly. Why do we call brain jelly? Because suppose you learn something, what happens? Your neurons create new connections, your neuron makes new rearrangement, If necessary for learning, your neuron will make a new branch and connect with somebody else or create a completely new configuration. Here also, instead of neuron, imagine helical channel organic gel network, helical nanowire, just like microtubule, like DNA, like alpha helices of proteins, to give the solution. And as soon as those frequencies come, they start producing these alpha helices like structures. They self-assemble into microtubule like helical structures. They self-assemble, make neuron like self-assemble structure. They assemble and then they make higher superior structures. So basically, you see in the normalized frequency, it starts from say gigahertz, megahertz, kilohertz, and hertz. And when we create it, so frequencies are generating those kind of things. Now we have to read it. So your brain-like jelly is there. You can understand the periodic events. So for an example, how do you know there is a rule in biology? Because you are a biologist, cancer biologist. And how do you know a rule? Because if you see it repeatedly happening, only then you make it a rule. The same thing is here. We observe from nature not 0101 bits. We do not put pixel like a normal computer. We look at only those events which are repeating. Why? Because brain does exactly that. So here in the brain jelly, that kind of periodic events are put together. So like imagine many clocks in a 3D arrangement. 3D arrangement of nanowires replicate 3D arrangement of clocks, periodic events. So we call it polyatomic time crystal or crystal means time crystal means just a clock. Imagine it's a block sphere or whatever. Now you see that blue light is coming from center. So we send single photon from there, and that single photon is divided into 16 different parts. And each brain jelly is there. Now you will find one interesting thing that the brain jelly light comes, and here is a camera. From this camera, each camera, 16 cameras which are connected, there is a screen in which by Wi-Fi signal is sent. There is, and then with camera we read what is there. So whenever there is a vortex produced, so quantum light goes through, and there are nanowires, helical nanowires, and combinations, and then you will see that those helical nanowire assemblies, they send light. This each helical nanowire has a beautiful property. They create nested spheres. Exactly the 3D clock assembly, but using light. So using the structure of light, we are able to read the material or neural network. So we are not making the brain as is or brain-like system as is, but we are using only its principle to do something different. So principle-wise, it's a brain, but physical operational wise, it's very artificial system, because we are taking the nanowires assembling. So they are doing. Now you will ask, even one jelly would do, why you have put 16? So we have created actually 47 different kind of organic gels, because in our brain we found that 47 different kind of neural circuitry are there, and also whole body neural network. 47 different kind of gels are there. So we took but 17 of them were selected, and 16 of them are here, all around in every single gel. But why do we need this 16 and on all these kind of things? The reason we need it is because um, suppose an event is happening, and you from there you take the 3D assembly of clocks. Now, when you look at it, then you find that I want to see this kind of symmetrical aspect, like um, how many numbers are there in the entire integer system divided by 2? 50%. Either odd or even. Odds are not divided by 2, evens are divided by 2. So 50%, so C2 symmetry, if I cut you by half C2 symmetry, you will be able to see all over the universe 50% of the structures. This statement was true 16 billion years ago, if there was at all a Big Bang when the universe got created. 16 billion years later, humans will not be there, they will be evolved into different species or disappear from the whole universe. Even then, C2 symmetry will be there 50% of the events. C3 symmetry, 33%, it will be there. So if you add C2 symmetry, C3 symmetry, C5, C7, the prime number of, you will find after 15 primes, you reach 86% of the events.
But universe is infinite, right? So how you can say that symmetry is there?
Yeah. So this is we physicists have, for an example, infinite materials are there universe. We have not reached there, but we know that they would always follow 22 different symmetries. More than that, not never more than that.
Okay.
Like if we have 100, so we don't know anything. I tell you now, you give me a number, 10 to the power 64. That many number of particles doesn't exist in the universe, known universe. But no computer can calculate. But I can tell you, if you go from 1 to 10 to the 64, 50% of the numbers are C2 symmetry, are even or odd. I don't need to go there. So I don't need to go other part of the universe to know what could be happening over there. So that is what physics is. So physics means I make a theory or I make a hypothesis. It's independent of frame of reference. So E is equal to mc square when Einstein discovers wherever you go other part of the universe, it will be U is equal to mc square only. So some fundamental constants, there are 15 or 20 fundamental constants like gravitational constant, you know, velocity of light. So several different kind of things are there. Wherever you go in the universe, uh, zillions and zillions of parsec far light years away, even human may not be able to go anywhere ever. Even there, 50% of the structure is falsities. 50%. So this is how the physics works.
Okay.
So physics, fundamental knowledge of physics is that we always try to find symmetry, arrangement, because number of, you can make it infinite combination, but number of symmetries always a few. So 86% I reach with 15 primes. With 150 primes, I reach 96%. So I don't need to go there, but I can predict 96% of the events accurately by going there. So now what we do not make a very complicated one. We go up to 86%, because 86% is a huge probability.
Yeah.
Because if you see the percentage of statistical probability published in the best journals in the world regarding quantum predictability and unpredictability, they are around 86, 80, 85%. On around 90%. So 86% is our target. Because we feel in our brain also, human brain also, 86% accuracy we have. So we have tried to match the quantum computer to the accuracy limit of the human brain, not beyond. We can, that will be much more complicated quantum computer. So this is a prototype that we are demonstrating.
Okay.
And we do not want to go beyond, because we want to show that in principle that this works. As a scientist, that's maximum I can do. And we can also commercialize, because if you are 86% accurate in predicting unknown events, then you can. It's kind of okay, kind of the kind of a thing. Because computer we have, we do not want to build another absolutely accurate computer. We want to predict unknown situation. Like we never decided that we will be filming this and Pushpendra will be taking and suddenly we decided and we started having this conversation on something. It was not programmed. It's not me to written instantly. I don't know the next sentence I will be telling, but I'm saying something. So each one has a special kind of jelly to promote particular kind of symmetry. Now C2 symmetry, C3 symmetry, C5 symmetry, C7 symmetry. So together, all together, 86%. Now your question, I understand, but how are you adding all these C2, C2, C3, C4, C5? That's where we are taking the help of quantum. So I told you now that we and you, wherever we are, if we are quantum entangled, even if you go to other part of the universe, something happens to me, it will happen to you. It's very difficult to believe, but you have to accept it as a truth. But you can never believe it, because it never makes any sense. Not to a physicist, not to anybody. But experimental proof for the last 100 years have shown that this is true. About quantum phenomena, everything that happens is true. Like to communicate you and me, I don't need to exchange energy. That's absolute nonsense. You can never believe it. You don't like that. Yeah, if the energy barrier here is say 100 kilojoule, and somebody can go from here to there with 10 kilojoule. In quantum world, all this is possible because they exist in a shared existence. So, as a biologist or as a general inquisitive person, if you keep the word shared existence, then you can understand every part of quantum. Now you see, single photon is coming and 16. So, photon knows that it is in a same state. Even though it is divided into 16, it knows it has only one state, one existence, shared existence. Just like suddenly you get a phone call from your mother from Kerala, and he says, "Is your health okay?" No, 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 I'm fine. No, 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 something happened to you. Tell me. And you really, 10 minutes back, you were feeling very, very much deep pain. You had it, thousands of people are having it, millions of people have had in the whole world, and you have heard this from many, many people that your beloved ones, their body starts shivering on something if you are in trouble, because their thoughts are so much connected. Even though you are staying in 10,000, 20,000 kilometers away, still you can feel. So quantum is much more profound than that. Their existence is linked. So if anything happens here and we find a C2 symmetry based particular single photon structure is generated, immediately that one also affect that one, that one, that one, that. So it's new things go there or go there, all change themselves, even though they are not connected. So that's why many people ask me, quantum computer is, it's a camera, measurement is done, and the camera is going there. How is it quantum? Why not you are taking one vortex from here, another output from here, putting it together, interacting it physically? Why not? We don't do it in quantum. So you imagine the futuristic hi-fi situation that you are doing your quantum computer. Part of your quantum computer is in planet Earth. Part of quantum computer in Alpha Centauri, and part of it outer galaxy somewhere, and part of it somewhere else. You are changing some of the states here. Some of the states automatically get changed, and all of these are operating in a complex manner. So together, we come here and the camera, and then from this camera, the vortex is generated, the outputs are coming, all of this, and we convert them. We see there is a periodic changes in the vortex, and that comes to this new situation here. From the camera, we will predict, and these circles or whatever the changes are happening here, that goes and we determine invariant as output, auto correlation of invariant. Now, what is invariant? For an example, you know the equation E is equal to mc square. M is invariant. Sorry, the c square is invariant because mass is changing, energy is changing, velocity of light is constant. So, discovery, a scientific discovery means you identify what is varying and what remains unchanged. In your biology, chemistry, physics, mathematics, engineering of any kind, always it is true. You find variables, link those variables with some invariant, your science is done. So we are creating somebody, a kind of quantum computer that is going to tell us an unknown phenomenon, periodically whatever happening, linking them, looking at the symmetrical aspect of different, making it perfect filtered, and give us the variables and invariants and a hypothesis. So this is a hypothesis generating computer. What are the application? How do we sell it in the market? So basically, big data is there. Huge amount of data continuously changing. You don't have time to write algorithm or something like that. So what do is you give those with a camera, you give those data continuously. Those data are changing and immediately telling you what could be the possible model. So instantly, without using huge manpower and resources, and then spending lot of time using human intuition and something, you can directly get into with 86% accuracy. Partially, you can give it to the human instantly live. A concept what might be happening in the data. So this is our what is our target with the quantum computer, and this is what we want to commercialize, packed it into a simple system, it's a usable, portable system, and that's what we want to sell it to the market and give the people an access.
So the actual application is
Predicting an unknown data, understanding an unknown data. What are the variables, who are changing, how it is changing, something like that. Not doing big calculations and other things like the normal computer or normal quantum computers. So it's a brain inspired quantum computer. So objective is only the getting a biological essence using some privileges of quantum. So our lab's objective has been to realize artificial brain. So we created this quantum computer as a version, because anything you create as a classical, you create quantum. Okay. That's all. Thank you, Pushpendra.
Okay.